probability that we got a type 1 urn is 0.8. But once you reach into that jar and pull out a red ball, now the probability that you drew from a type 1 urn is no longer 0.8, but you should readjust your probability to 0.64. So again, if you're in a forced wager situation where you have to bet on whether or not the urn that was drawn from was a type 1 urn, and someone tells you, hey, I'm privy to the information of what kind of ball was drawn out of that urn, it was a red one, you should readjust your assignment of probability that you drew it from a type 1 urn from 0.8, your prior probability, to a posterior probability that you drew from type 1 urn, given you drew a red ball, to 0.64. This probability falls from 0.8 to 0.64. It's still likely that you drew from a type 1 urn because of the distribution of total urns in the room. But once you know a red ball is drawn, this probability should fall from 0.8 to 0.64. At least as a rational agent, that is the probability you should assign to the fact that you drew from that you drew a type 1 urn based on the fact that the ball drawn was red. I hope you're seeing just how important Bayes' theorem is for the assessment of probability in decisions under risk. It gives us a way of reassigning probabilities to outcomes in the light of evidence in a quantified numerical fashion. Absolutely crucial for the point of assessing decisions under risk, the central notion of probability.